This meeting is now being recorded.
Okay. And so we will get started. Remember, if you have questions, you can use questions and answers or the public chat. And I'm going to move, and I'm going to let John O'Donnell come in here and start his presentation. So thanks again, folks.
Good afternoon. As Tom said, my name is John O'Donnell. I'm Director for Environmental Services for DCAM. And as such, I wind up covering a variety of different types of problems, both in buildings as well as around buildings. And today, we're going to talk about asbestos in buildings, and then also about PCBs, so that things that are really relevant, I think, to building managers, especially buildings that were built before 1980, will give you a sense over what is asbestos, how do you manage this material, how do you abate it, but a very key component is related to the communication. All these materials, PCBs and asbestos, potentially have health impacts, but at the same time, they are incredibly well regulated. And it's not a case of like the Wild West where people just go out and do things on their own and there's nobody keeping an eye on them. They're actually heavily regulated with both EPA as well as Mass Department of Environmental Protection. So with that, let us get started on the asbestos portion. What we're going to cover today is what is asbestos and common materials that contain asbestos inside. A little bit about the regulatory framework. We're just going to touch on a couple of the key parts, not talking about all portions of the regulations. A little bit about how it's removed, and then how operation and maintenance can be done of these materials in your building. Because even though you have asbestos in a building, you're not required to take that asbestos out once you find it. You can manage it in place. And then the last, obviously, is the communication, which to me is a key component, is both to keep your employees as well as the occupants of your building calm and able to say, okay, things are being taken care of properly. There's not a risk to these people while they're doing their daily jobs. And as such, it does not need to be a panic situation if someone finds out that there is some asbestos in the building. What is asbestos? Asbestos is a mineral, and it basically is a long fiber type of material. And there's a couple different classes of asbestos, one of them being serpentine. And then the other one, which covers several different types, is not really as commonly used. A piece of trivia for you is that the state rock for California is serpentine, because California has a lot of asbestos out there of the serpentine type. And so when actually I've given a presentation in California and talked about asbestos, the people were looking at me as though I was a little crazy that we were so paranoid on the East Coast with asbestos compared to them living with it day in and day out as a natural rock that they run into every single day. It is referred to as a magic material and a mineral because this material is flame retardant, it has a lot of strength, it has a lot of great characteristics, and obviously there's health impacts if it's improperly managed. On the side of the slide, you can see a penny, and it kind of gives you a sense of what we're talking about for how small these fibers really are. You can see 2 to 3 grains of rice on the one side. You can see a couple of human hairs, and then you see there's 20,000 asbestos fibers in that small circle that is on the right-hand side of the slide. Asbestos is essentially everywhere in our modern world. It is used for everything from brake linings and all kinds of materials inside of buildings. The ones that we typically run into quite a bit is going to be related to both floor tiles and mastics, as well as caulking that's mostly glazing, the material that's inside of a window between the panes of glass and the little framing that goes around inside it, the mullions. The other place you see it is related to insulation on piping. Those are probably the 3 biggest places that we run into it on a regular basis, and therefore most commonly the ones that we have to be able to deal with. asbestos in human health. I mean, it would be inappropriate to, something happened here. I'm not sure.
To the arrow. Yeah, to the arrow. Just click on the arrow.
Okay. Asbestos in human health. I'm sorry if I'm not sure what happened to the slide information here.
Click on the arrow.
I'm sorry. Somebody changed my slide. But a key component is that a lot of people believe that asbestos has been banned in the U.S. and that essentially since 1978 it is no longer in production, it is not being used. If you go to Home Depot and look at roofing tar, you will see that chrysotile is listed as one of its ingredients, an asbestos mineral. So although asbestos is much more regulated than it's been in the past, it is not banned and it is still able to be purchased and used because it is a product that when properly used is very, it's magical. It does what it needs to do.
Click on the arrow.
What the problem as far as human health goes with this is that these asbestos is very, very small fibers. And that those fibers, once they go into the air, stay into the air quite a long period of time. They just don't simply drop right back out again like dust particles, but they stay in the air. And it's easy for you to inhale those materials. And when you do, they get into your lungs and into your digestive system. It is known that asbestos can create asbestosis, and it's also mesothelioma is one of a cancer form of asbestos. This is all related primarily to your lungs. And what it is that these very, very small fibers that are generated, that are the asbestos fibers, they go into your lungs and they basically like snag onto your lung. And as you're exposed to a lot of asbestos over time, these little snags build up and start to reduce your lung capacity because all of a sudden that's an area that no longer can function the way it is supposed to. Where you see a key part of this is asbestosis is related to people who worked in shipyards because one of the biggest things is that those guys were working in shipyards with their faces essentially inches away from pipe insulation, and those materials were basically, the dust was getting in their lungs day in and day out. My father-in-law had asbestosis. He had it for a long time. Actually, he passed away for other reasons than that. But as he said, back in the 50s, asbestos was considered a miracle mineral, and people were using it for all kinds of reasons, and those health issues really were not understood at that point in time. The key component to understand about asbestos, and this is a critical for you to understand, is there's a real difference between what is called friable and non-friable. The friable material is basically your ability to take a material and to, with your hand, crush it into a powder, turn it into dust. The non-friable is essentially everything else. So when you have floor tile or you have a mastic, the material that's underneath a floor tile that contains asbestos, those materials, unless you break them apart, simply do not release asbestos. In the case of the mastic, it's like having a tar, and these little fibers are tied up in the tar, so it's very difficult for them to get into the air. So your exposure to mastic is nowhere near the same thing as being exposed to things like pipe insulation that is now in a powdery form. One of the things with asbestosis and with mesothelioma is they have long latency periods. You're not going to see the impacts immediately. This is not like being exposed, say, to cyanide or something where within days, hours, you begin to feel an impact on your life. These are things that can take up to 40 years to begin to impact you. And one of the things is if you're handling asbestos, even the materials like the floor tile, is if you're sanding that or you're sawing into it, drilling or grinding, you're creating dust. And that creation of the dust, again, is putting the fibers in the air for your ability to inhale those materials and obviously start to impact your lungs over time. friable, here's some examples of different friable materials just so you can see. One of the key ones is the spray-on materials. That's in the upper right-hand corner. You can see that the steel was covered with a material that the guy in the white suit is knocking off, and that material contains asbestos. And the concept is that because a lot of buildings have steel frames with concrete decking above, that steel frame helps to support that concrete floor. In the case of a fire, if that floor, the steel, is to be heated up to the point that it begins to melt or to change, to deform, you have the potential for the concrete floor above it to collapse. This is what happened in the World Trade Towers, in that the steel buckled under the heat of all that jet fuel, and as that steel buckled, the concrete around it collapsed, creating the situation that occurred. So the material, spray-on was put on all kinds of buildings. We see it a lot of times. You also see it on things like your pipe and boiler insulations. In cases, you will see it on your insulation for your ducts. Some of the ceiling tiles have it. Not a lot, but some of them do. And a case that we see occasionally is materials with like gypsum wallboard, is the joint compound actually has asbestos in it in certain cases, so that once you paint that entire wallboard over, you can no longer really tell where the asbestos is because you're not sure exactly where the screws were put in to hold this material onto the studs and where the joints were. And again, you see things like fire-rated doors. Non-friable is things like the floor tiles and the mastic, and that is in the bottom left-hand corner. You can see the floor tiles, and the black material in their photograph is actually the mastic. Like I said, it's a tar-like material that's a glue that holds the floor tile down and connects it to the underlying substrate, which may be a concrete deck. The other place you will see it is if you look on the upper right-hand photograph, is that you can see for all these window panes, this material that's around them holding the pane in place, that's the glazing. And a lot of times that had asbestos in it, as well as the caulking that goes on the outside of the window holding the frame and basically creating a watertight seal between the frame and the surrounding brickwork or whatever that other material is. You'll also see it again on things like roof shingles and drapes and curtains. Just a quick question is, you may wonder what this is here. This is a piece of transite pipe, and the transite pipe, this is actually used for domestic water, and this was used commonly throughout the 50s. It continues to be in the ground in a lot of facilities. If you go to the city of Salem in Massachusetts, almost all the water system up there, it runs through transite pipes. One of the things that's very different is that when you're looking at things that you may inhale, you are talking in things in the fibers per cubic centimeter, very small numbers. When you start to look at what flows through a pipe, you're allowed under EPA up to 7 million fibers per quart of water. So we're talking is that drinking asbestos-containing water is substantially different than actually inhaling it. So you have to understand there's a real difference because this whole thing about friability really controls how you're impacted with your health. The federal regs. The asbestos under the feds is looked at as being anything containing more than 1% asbestos fibers. And you're regulated under two programs, really. OSHA, which is for worker protection, and we're giving you the citations and the regulations. And the other part is US EPA, because they manage this under NESHAPs. They also have a program that was set up to handle things related, AHERA, which is related to abating materials inside of schools. And the AHERA program is set up to say, once you remove that material, how do you make sure that the children going back into that school are safe? So there's a whole series of much more stringent requirements related to testing and other things in order for children to go back. One of the little known pieces is that underneath AHERA, actually public buildings are subject to the AHERA regulations, unlike a lot of other buildings. that, as such, the HERA program is much more stringent and actually is if you want to call it, a more robust system for dealing with asbestos. In Massachusetts, there's two parts that really manage, well, there's three parts. The key one is the Department of Labor and Standards, and they basically protect both the workers and the public. The DEP is really focused on much more is how do you prevent this material from going into the air or into soil or into other media while you're either removing it and then making sure you properly transport and dispose of it. The last one I put in here is the state sanitary code because that regulates asbestos in housing. That typically, as a facility manager, you're not going to deal with that, but I thought this be a point for homeowners just to be aware. And that one is implemented by the Board of Health. Now, Massachusetts has actually taken NESHAPs and has become a lot more rigid on how this is handled. There really isn't a threshold for the amount of asbestos that they get concerned about. The greater than 1% number is a key number under EPA, but Mass really tries to go below that to, again, for more protection. So it's a much more stringent requirement than the feds. Department of Labor and Standards, they have the responsibility, as I said, to protect the workers and the public safety. But they also have is the requirements for who can actually manage the asbestos. And their program is very, very regulated. You have things from people who have the ability to identify asbestos, which are the inspectors. And those are the people like you or I may go out and look at material and say, based on experience, we're pretty sure this has asbestos in it. But we're not really qualified to be able to make that determination. These inspectors go through a whole training process to be able to look at materials and be able to properly sample them and then to do some testing to be able to say, yes, there is asbestos here, and go forth with that. When you go to take asbestos out of a building, you now start looking at asbestos contractors, workers, and supervisors. So that's the people who actually want to do the abatement. But when you do an abatement, you're required to have a monitor, an asbestos monitor, again, who is licensed through DLS. And that person is to make sure the regulations are followed and also who at the end of the day goes through the area that's been worked on and provides clearance to say that that area has been properly cleaned up and that people can return to the area that's been worked upon. There's other categories, too, related to both designers who put together specifications as well as management planners who are going, when you're just trying to manage the material in your building and putting together like an operation and maintenance plan. You're only allowed to use DLS licensed certified consultants for work in Mass. This, again, is very well regulated. A little photograph down in the right-hand side is a card that someone has that shows that they have that license, and you can see there's expiration dates on it. When DCAM does a project, one of the requirements is that before anyone can work on an asbestos project with us, we have to see these cards because we want to make sure is that we're not just getting somebody who was pulled off the street and is working on this project. We actually had a case one time where we had almost 20 asbestos workers on a project. And it was amazing because every one of them had a different photograph, but every one of them had the same Social Security number, which was really strange. But it kind of gave you a sense, and this goes back about 15 years, DEP has gone a long way to trying to get those people that are trying to do this on the side, on the quick and dirty and just move forward, to move those people out of the business and only keep those that are properly certified. But this is something, if you do have a project that needs asbestos abatement, asking to see these supervisor or worker license is very reasonable to be doing. One of the things we mentioned was that you have to find out if you have asbestos in the building. And again, having somebody who's an inspector go through the building and look at the different materials and identify which ones may be asbestos, and also to take a look at those materials to determine whether or not they are in good shape or whether or not they are basically falling apart. Now, what your inspector is going to need from you as the building manager, if you're doing a project, is what's your purpose? Are you doing a demolition? Are you doing some renovation? Or are you doing some incidental maintenance work that may be required in the case of perhaps drilling holes through the floor to be able to run electrical cable or communications? All these things will impact is what the scope of your survey may include. You can do a survey for the entire building. DTAM has, for a number of its buildings, done complete surveys of where the asbestos is in the various buildings, including the State House, so that when we go to do a project in the future, we already have a good sense over what we're going to be impacting because we've already done our survey of the entire building, and therefore that information is available to help guide us when we put together the plans and specifications to perform the project. When a consultant does come in and does his site reconnaissance, he's going to look at the different work areas that you're asking him to work in to look at, as well as what materials that might be impacted by that project. One of the things you will see consultants sometimes tell you is that they're going to take 20, 40, 100 samples of materials. Under the AHERA program, it's actually very clear that the number of samples you take is much more focused on how representative materials are. So if you have a building where essentially everything is 12 by 12 floor tiles and they're all white, it doesn't make a lot of sense to test every single floor tile. Instead, you can take a relatively small number of samples, 7, and be able to draw an opinion as far as how this material, what its condition is. And once you find one sample that has more than 1% asbestos, the consultant will stop analyzing them because now you've shown that there is asbestos and you're never going to be able to identify that this tile is hot, this tile is not. But you start looking at things back to being homogeneous. If you have brown tiles in one place that are 9 by 9 and white tiles that are 12 by 12, those are two different materials and they're different colors and they should be looked at separately because you don't know when each of those was put down and you're not sure what those materials may have asbestos, yes or no. The key thing to think about, though, when you're looking at things like floor tile is the material underneath it, the mastic. A lot of people will go ahead and say, we have asbestos floor tile. The floor tile is not that difficult to take up. The problem is that the underlying mastic is a tar. So to get that material off of a concrete deck takes a lot more effort. It takes either solvents or snow blowing. It takes a lot of different things to go with it. So it's key to not only look at the surface materials, but what's underneath it. And you also want your consultant to evaluate these materials. Are they good, they're fair, they're poor? And photograph them and, of course, mark them on a plan so that in the future you know what you've tested in the past so that, you're saving money moving forward. What typically is run for asbestos is polarized light microscopy, PLM, which is simply a microscope-type approach of looking through there at the materials to determine if they have asbestos. And again, we're back to somebody who is certified to be able to look at these materials. The question is, if you find asbestos, do you have to remove this material? And again, as the first bullet indicates, is that if the material is in good condition and it's non-friable, there's no requirement that that material be taken up. That being said, is if you're going to touch that material in the during your project, that you have to take floor tiles up again to put a hole through a floor for electrical work, you're going to be touching that tile. So even though it's by itself, it's in good condition and it's okay, there's no requirement to take it up. You have to take it up as part of your project, and therefore the requirements change on how you're going to deal with that material. So you want to keep this material in really good condition because obviously you can spend quite a bit of money taking asbestos out of a building. In some cases that removal is not necessary and may just be incurring costs. But we're back to the thing about communication, is that if you do have asbestos in your building, you want to make sure is that particularly your employees are aware of where that is so that when they do an activity that may impact that material, they can be properly prepared to deal with it or bring in outside abatement firms to deal with it properly. If you have materials that are damaged, they can be repaired in some cases, such as wrapping them with different types of fiberglass materials. Typically, pipe runs, like the one in the bottom right-hand corner, that material can be abated relatively easily and replaced with new and insulation fiberglass that will just slide over top of that piping. Where it becomes difficult is when you get to the mudded connection. That's where you have like an elbow or a T-section in your piping. Those things were never really able to just be fit easily with asbestos materials. And as such, they put asbestos in like in a cement and essentially just put it around the connection to try to keep the heat inside that piping. As such, those units, you have to almost chip them off to get them out of there, which is a lot different than basically being able to cut a piece of insulation tile or piping and be able to unfold it and get it off the pipe. If you're going to do any kind of demolition, you have to do an asbestos survey before you do it. Bullet number 5, which talks about that all the asbestos has to be removed, one of the key components of that is you have to look and make sure is that the building is safe. If you have a building that is 3/4 of the way on the ground, you can't be expected to send people inside of there to do an abatement. In that case, you're forced to send the entire load of material off as asbestos-containing waste because you cannot segregate the asbestos out of it. So, but you do need a survey before you do a demolition project to identify asbestos and see if it can be abated prior to doing the demolition. And the last point is EPA's advice. If it's in good condition, leave it where it is. Taking it apart has a better chance of putting fibers into the air than leaving stuff that is in good condition where it is. Here's some of the work practices that you perform when you're doing asbestos abatement. In the photographs on the right-hand side, one shows a whole area basically being prepared with plastic to control all the fibers to keep them inside of that area. And the bottom on the bottom is what's called a glove bag, which is typically about a 3-foot long section of plastic that you wrap around the pipe, and then they can go in and cut out a piece. So if you're doing repairs on a pipe that you need to bring in a new T-section or a new valve or whatever, typically you'll use a glove bag to be able to focus on the area that you need to get to and do it safely, but at the same time not wind up creating the situation in the upper photograph in which the whole space has plastic and a lot of other things that we'll get to in a second. All these things require that you have an ability for the materials that are inside the work area not to get to the outside. And as part of that, what you create is this airlock decontamination zone. And it's simply what looks like a tunnel. And basically, as people go into it, they can change from their street clothes, put on their white suits, their respirators, and then go into the workspace, and they come back out through that same process. And that becomes the only way in and out of the work area so that you control access to it and make sure only people who are properly trained can get into there. The other thing you will do is you will put that space under negative pressure. And what that means is that you turn a vacuum on inside of that space so that air is pulled into these HEPA filters and then exhausted out of the building. The HEPA filters capture the asbestos, and then the air is released to the outside. And that negative pressure pulls air in. So if you can't get the plastic, as you see in the upper right-hand side, to capture every seal and to make it very perfect, it's constantly pulling air in so that the people on the outside of the work area are not being exposed to asbestos fibers. And as it says, there's multiple stages of filters that you build with these HEPAs. And the other thing, too, is you try to keep everything very wet, or not very wet, keep it moist. Because if the material is moist, the asbestos fibers do not go into the air. They drop essentially to the ground, in which case the issues we've been talking about all along from a human health point of view back to fibers getting into your lungs are being controlled. And as I said before, is that once you're finished with the abatement and they're assuming everything is done, you then have an asbestos project monitor go through it to confirm that that space has been cleaned out and that air samples are taken to show that there is nothing in the air. Now, you would sit there and say, okay, potentially if you just let everything drop to the bottom, to the ground, if somebody takes an asbestos air sample, there might not be anything there. Under the ADHERA program, you go in there with a leaf blower, and you basically blow everything you possibly can off the ground, off of any surface, and put it back in the air before you do that clearance sample. And that leaf blower is pretty significant at making sure everything goes back up into the air that falls. So you have a very good test to see whether or not you've done a thorough job of doing your abatement. If those samples come back and say there is still asbestos in there, the contractor is required, before he turns off the negative pressure, to go back in and clean the space again, and then another round of air samples are taken. This is a case that's done until there is nothing and you meet the criteria of what's allowed into the air. This shows a schematic of on the left-hand side is the decontamination chambers, the three of them that go into the space, the area that's been blocked off and sealed with plastic. And on the right-hand side is the HEPA filter, which is connected to a large powered fan, and then the air is blown outside. So the air that is sucked into the HEPA collects the asbestos fibers and then allows the clean air to go back out to the outside air. Just some photographs to show you typical types of things. You can see the plastic on the upper left-hand corner. A typical decon system is there on the right-hand side, upper point, with its three small chambers. The bottom right is one of the high-energy fans, the blowers, that basically create the vacuum to suck the material out. And the one on the left-hand side shows you the plastic that runs from that blower after it goes through the HEPA filter, and then takes that material up and vents it to the outside. So one of the things that gets into when you're designing an abatement process is how are you going to get that air out of the building or out of your space? If you're doing interior work, you have an issue because now that material, how do you get to an outside? Do you have windows that you can go to? Do you have vents that take you to the outside and do not discharge to other areas? So doing an abatement project inside of a building needs to be carefully thought through before it proceeds. I talked about air sampling briefly, and as I said, clearance samples are the ones you take after you are finished with the abatement, and that's before you allow the contractor to take things down. A lot of times what you will do is you will take some air samples before you even start numbers to get in a background number. I have yet to see someone do a background level before they start a project that has any asbestos in the air, because obviously if that was the case, you have a problem to start off with. The other thing that DECAM will typically do is run samples outside of the containment area throughout the process of the abatement. And that reason is to reassure the occupants of the building that are still in the building during these projects that they are not being exposed to asbestos. I mean, having a negative pressure, having the plastic, having all these other safeguards is fine, but most people feel comfortable being able to say is that there was an air sample taken, and that air sample shows that they were not being exposed to anything. I have my leaf blower there on the left, and on the right-hand side just shows you how the system works for taking air samples. The little black tube at the top there is where the filter is for pulling in an air sample, and the gray unit on the bottom is a pump that pulls the air through that filter and then vents and so that everything is collected on that filter. The material you take out from an asbestos project, where does that material go when you're done? It's regulated as an asbestos waste by Mass DEP, and it has to go into an approved landfill that has the ability to take this material. Currently, there's 2 landfills in Massachusetts that are permitted to take asbestos waste. One is up in Fitchburg and one is in Chicopee. That being the case that they have a permit that says they can take asbestos, I don't believe they have taken asbestos for at least a year, Chicopee maybe 5 or 6 years. So although they have a permit, they're actually not taking in the asbestos. The business decision on their part is that they don't want that material into their waste stream, and obviously you can't change the fact that, you know, they're running a business and they decide they don't want to take asbestos, even though they have a permit. That is obviously their choice. So typically asbestos that is generated inside of Mass leaves the state. It can go to almost all the surrounding states. Turnkey up in Rochester, New Hampshire is a big one for taking material. There are a number of facilities in New York State, and those facilities, You have to know whether or not you're shipping them friable materials or non-friable. Are you sending them a lot of floor tile, or are you sending them pipe insulation? Those obviously impact what the costs are and where these materials can be taken to. Now, a key component from a facility point of view is the operation and maintenance. I mean, things you need to know about inside your building is is the asbestos? Is this material that is going to be every day dealt with by your employees in the building, your maintenance staff, or is this material is only in mechanical spaces that have a much fewer people being exposed and not on a regular basis? The goal of your operation and maintenance program is to minimize that exposure, not just to the building occupants, but also to your employees. I mean, we owe it to the people we work with that, you know, we're not putting them in a situation where they're being exposed to asbestos, particularly friable asbestos. And this O&M program has to basically deal with things like, what's a typical activity that you're going to be doing that really has no impact touching asbestos? I mean, dusting the top of bookshelves is not something that's going to generate an asbestos problem. What kind of things are you going to do that may have a problem with asbestos, such as if you're working above the ceiling, a suspended ceiling, and there's asbestos on piping, steam pipes above it. Perhaps somebody's going to nick those pipes. If they're nicked, there's ways of dealing with it that are very easy to do and be able to move forward on. And again, the last one being is, what are those things that you're going to do as part of running your building? Drilling holes through walls, drilling holes through the floor. Those are activities that are going to occur on a common basis as you just simply run your building and have to deal with, you know, small changes that happen in spaces, particularly as technology changes and we move from different things like coax cable to fiber optics, you know, to routers. So all those changes in technology potentially have an impact on your building over what materials are going to be impacted and how they're going to be impacted. The thing is that your O&M plan is going to be a guidance document. It's not going to be a substitute for regulatory requirements. It's going to tell you what things you should be doing in your building, what your people can do, and what basically needs to be subbed out to contractors. As I said in the second bullet here, the O&M plan should cover all these key points. One of the problems that we have run into on a regular basis is number 2 on the bullet list, which talks about the key staff, including who's the keeper of the O&M plan. We all have a tendency is that as we operate on our building and something happens such that we have to go drill some holes or we got to take some tile up, we don't document where that was done. And a thing that will make life easier for you as a facility manager over time is keeping that record so that if you do a space and clean the asbestos out of there, like floor tile, that you're then aware that that room has been done, or people who come after you are aware that that room has been taken care of and has been properly abated, so that work that gets done in there in the future is not going to need the same level of protection and precautions that you would do in a room that's never been touched. But if you don't keep track of where you've done this work, you're not going to be able to be essentially cost effective, because you're going to keep going assuming that the material's got asbestos in it and may not. So keeping of these records is a key component to be able to make the building function and allow you to be more cost effective, and eventually, in a perfect world, all your asbestos would come out of the building. The photographs on the right-hand side are just showing that there's ways of doing wraps on piping and materials so that although you still have asbestos, you control this exposure out there to the general public and to your employees. You have to understand that this O&M plan is living. Every time you do something, you need to document it, because you really just want to make sure you have a good record of what is going on in your building. And this is key. We run into this problem all the time, is trying to make sure we keep those documents up to date. One of the things is, obviously, asbestos is a scary word. I mean, we've all seen the ads on television, and the upper right-hand corner has one of the similar ones is about if you might have been exposed to asbestosis, you may develop mesothelioma. All of this is, you see it daily on there. As such, the A word is a very scary word to most people. So you have to be able to handle clear and accurate communications when you're doing projects in your building. Or even if you're not doing a project, your employees, your maintenance people need to know where this material is and what they should be doing and what they should not be doing. This all goes into like assessment training, just so your people are, you're controlling a liability and you're also making sure they're safe. You also have to remember that the people that you're dealing with in your building, you have both your employees, you have the occupants of the building who may be from different agencies and not necessarily working for you as the facility manager, and in some cases you have the general public. So what you want to do is be able to manage information properly so that you're keeping people calm. Again, this is a well-regulated process, and as such, you can do a lot of things to basically that are right beside the regulations and are required and are going to be done anyhow, but are going to show people that they're going to be safe while you're doing this work. Informational pamphlets, like on the bottom right-hand side, DCAM has used, is saying is, okay, let's just let people know, you know, what work is being done, where's it being done. You know, is an area being closed off? And people begin to wonder, why is the southwest corner of the building suddenly have all kinds of plastic wrap on it? What procedures are you following to mitigate the risk? We talked about the HEPA filters. We talked about the blowers, the fact that you have all this plastic that you put up around it to minimize exposure, the air samples taken during that process of doing the work, as well as the air samples that are taken at the end of it to show that it's been properly cleaned. Providing information over what agencies regulate that. And the key one is being, what information do you have, who do they talk to, and where can they get more information? And one thing that's key is signage. What DCAM has found that works fairly well is that when you're doing an asbestos project, you are supposed to have signs that say asbestos, you know, do not enter and things like that. But you don't necessarily need to put those things at the end of, in the elevator lobby, right where everyone getting off sees these large signs about asbestos. If you have a car door that leads off to where the actual work is being done, we've actually installed a wooden door, temporary door on there, and that door is locked during business hours. And behind it is the signage that tells people that if you go past that door, you're going into an asbestos area. Again, it's just trying to minimize miscommunication and have the people be aware that, you know, it's being handled properly, and it is not an issue. The asbestos from DEP, here are their 4 DEP regions, and which list who the key people are to talk to in those regions. If you have questions about asbestos, they are all very good people to work with, and they're more than willing to tell you information about how the projects are going. And if you have questions, and again, we will answer any silly ones. If anyone has a question right now.
Hit the question and answer thing just to see if anybody, no, okay. Exit out.
Okay.
Okay, you can keep going.
I will.
I'm going to go check it out next meeting. I'll be back.
The second part of this presentation is related to PCBs. PCBs are polychlorinated biphenyls, and they have become much more of an issue over the years, particularly in building materials. In the past, you focused on PCBs and oils. Transformers used them all the time. PCBs were great because you could actually let the oil heat up quite a bit, would not let the oil break down as readily. So such the oil did not need to be changed out of transformers more frequently. However, it has become now an issue inside of buildings, particularly related to caulk materials. there's some information about, what are PCBs, again, where are they, operation maintenance, PCB removal, some of the work practices, and communication. The key thing from this next slide, which is talking about the PCBs, is two things. One is that the term you will hear most often is a word called allochloros. And allochloros was what Monsanto, who manufactured PCBs, is what they called their different products. And they had different allochloros for different uses. Typically ones you will see in a building, say for caulk, is going to be what's called 1248, 1254, 1260. And those numbers are related to how much chlorine is on the material. But allochlor you will hear over and over again as being the word. The other one is the regulation that covers PCBs is TSCA, TSCA, Toxic Substance Control Act of 1976. A lot of programs, including asbestos, has been delegated from EPA down to the states. TSCA has never been delegated. It is totally an EPA program that you work within. The only place that it's a little different is if you find PCBs in soils, in which case Massachusetts Department of Environmental Protection has regulations related to those releases to the soil. The PCBs, they are everywhere. There's studies have been done that found that the only place that they have not found PCBs is in a desert in South Africa. Other than that, this stuff is widespread at low concentrations essentially everywhere. Places that you will deal with it more inside of buildings is the key one is going to be around window caulking, as shown on the right-hand side. The glazing compound, we have seen some of that, but not quite as much. There is material in older light boughs, and one of the problems with that is that if you have bulbs that have been burned out, those bulbs, the boughs continues to try to fire, and as such it heats up the little bit of PCB oil that's in there, and those PCBs then go into the air. And you have to assume is that if you do not have a sticker on a ballast that says no PCBs, that it may very well contain PCBs. As I said, there's a number of places down below to talk about where PCBs were used. But one of the biggest ones that we deal with on a regular basis for buildings is the caulking. The material is put between the window frame and the surrounding brick, concrete, or whatever. And that material, the PCBs allow the caulk to be very, very pliable and able to expand and contract. So if you have on the outside of a building where it's on the southern side of the building, those temperatures outside may vary anywhere from 0 to 100 plus degrees. And what you need is that as the different materials expand and contract due to the heat, you want the caulk to expand and contract so that it keeps a watertight seal between them. And PCBs do that job excellently. We've looked at buildings that have been, PCB caulk has been there for 40 years, and it looks like it comes out of the tube. We did a project with the EPA, in which case they took a piece of caulk out that was about 3 feet long, and the guys from EPA were tying it into pretzels. I mean, 40 plus years, and it looked like it was brand new. Also was loaded with PCBs. So the material was doing exactly what it was intended to do. One of the problems you run into PCBs, unlike a lot of materials, they stay where they are. With PCBs, the PCBs actually come out of a caulk. If the blue material in the middle is a caulk that has PCBs, they will migrate into the surrounding substrate. They'd be that brick, concrete, wood. It will not go into things like steel, will not go into aluminum. Glass it doesn't go into, but if you have bricks and all, the material will go into the surrounding material. Now, one of the problems is that if you put a brand new caulk inside to replace PCB-laden caulk, the PCBs have a tendency to migrate back into the caulk that you just cleaned up. And this is all referred to as a concentration gradient. So it wants to go from levels of where it's higher concentrations to places where there's no concentration. So the material will migrate back into it. The key thing is that all caulks are not created equal. We have found is that on the same building, materials look identical because PCBs were added in the field. Sometimes it appears as though Monday afternoon, things may be a little different than what you see on a Wednesday, and Friday afternoon they may not have put as much in because they were just trying to get out of there for the weekend. One of the things also is the materials that the PCB caulk is up against. Are you talking that you have precast units like the upper left-hand corner, planking? Are you talking concrete masonry units, the CMU in the bottom left-hand side? Are you talking poured-in-place concrete, the middle picture where the man is putting together the forms? Or are you talking bricks? PCBs migrate differently depending upon what materials are in here. One of the problems we've run into is that in the middle picture with the guy setting up the formwork for pouring concrete is that you put a releasing agent on the form so that the form can be taken off of the concrete easily. In some cases, the oil that was used to basically be the releasing agent actually contained PCBs, and you wind up having the concrete containing PCBs that have nothing to do with caulk or anything else, but is totally a function that the releasing agent that was used has some low levels of PCBs into it. Some management things, just so you're aware. I mean, basically, if you have a building that was built between 50 and 78, you have a chance of having PCBs. However, one thing is not all buildings built in that age necessarily have PCBs. A lot of times you can look at the caulk material, and if the material is really dry, really brittle, and it's cracked, then there's probably very low PCB content or none. Again, if the material looks as though it just came out of the tube yesterday and it's been there for 40 years, the odds are probably pretty good you do have PCBs. If you look on the right-hand side there, of course, as time changes, different levels of material are installed such that you wind up with several layers. So when someone's doing some testing for you, they need to look all the way down to the original material because that upper level may be very looks like it's brand new, but you don't know whether or not that was installed 10 years ago, 5 years ago, or whether or not that's the original caulk. And obviously, if it's the original caulk and it's that pliable, then it may have PCBs. If it turns out that the underlying material, which may be more representative of what was there in 1970, might be very much cracked and decaying, and that just some new caulk was placed on top of this, and as such that this underlying thing is indicating that you may not have a PCB problem at all. The materials, as we said before about substrate, is that the PCBs migrate into porous materials like wood, bricks, concrete masonry units, concrete, and the others, and they may need removal. The non-porous stuff like steel, granite, and glass, they're usually not impacted. And you can usually clean them to the point of making the caulk, taking enough of it off such that you can go ahead and have a non-PCB issue. The one you have the biggest problem with is structural concrete that's up against PCBs because there may be some migration into the structural concrete, but you can't simply remove that concrete without a major structural problem to the building. And unless you have money as no object, it's very difficult to say is that you're going to actually go into a structural column. We ran into this at a site where we had a structural column was 12 inches by 12 inches in size, and the consultant did some testing and came back and told us that we needed to take 2 inches off of each side of that concrete. So a building that was being supported by a 12-inch by 12-inch column suddenly was going to be supported by an 8-inch by 8-inch column, in which some of the reinforcing steel was now going to be exposed. And so we were asking the consultant if they were willing to stand underneath the building while we took these inches of concrete off. And they quickly understood is that you really can't do that. So you have to look at other measures on how to deal with PCBs and structural concrete. One of the things is how do you sample for PCBs? And questions come up is why are you doing it and what are you testing? If you look in the right-hand upper picture, you see 5 little holes. The EPA has very specific requirements on how samples are taken and how deep they are going to be, and it requires a lot of times that you take multiple samples to create enough of a sample to go to a laboratory to test it. In the bottom left-hand corner, that was a core through an entire wall that included both concrete masonry units, reinforced concrete, brick, as well as a void space that was inside the wall. The right-hand side on we're showing the pencil is one of the easiest ways to be able to get a sense over what your PCB concentration may be, is to take a sharpened number 2 pencil and push it into the caulk. And if you can pull that pencil out without breaking the tip, and it's the original caulk, you probably got a PCB problem. If the pencil tip breaks, probably your concentration is either low or maybe non-existent. And that's the fast and dirty test to be able to get an idea of what's going on before you actually spend money in a laboratory testing it. And the unit in the middle is just an air monitoring system, so when you're doing abatement, being able to document what exposure is going on into the outside air. There's several different types of materials that you're dealing with, and this just gives you a sense more from a cost point of view than anything else, is that things called a bulk product, which I'll explain in a minute. You're talking about $120 a ton. They can go to different landfills. Unfortunately, there's none in Mass that will take it, and you wind up typically going like to Minerva out in Ohio, or you may wind up going to Turnkey, although Turnkey keeps changing its mind on what they will accept and what not. If you choose not to take out the material around the caulk, you may wind up with a material called remediation waste. Remediation waste can only go to what's called a TSCA landfill. And as you can see the pricing that you suddenly are looking at per ton, this is not including getting it there. So you're shipping things to Model City, New York, which is out by Niagara Falls. You're going out to Michigan. You're going to Utah. So you can see what your trucking cost is going to be above and beyond what these costs per ton are. However, if you can't take the material out, like structural concrete, you do have ways of being able to encapsulate it, and there's a lot of requirements that then kick into place for you to manage this material going forward in time. So some of the things that go with removing PCBs, again, we have the guys in the white suits with respirators. We have 3-chamber decontamination. A lot of procedures that you do for asbestos are similar to what you do for PCBs. And for long-term management, okay, you have a chance that, or potentially you can encapsulate materials. However, once you encapsulate them, the EPA has requirements that says is that you have to start looking at them on a regular basis to determine whether or not the encapsulant is working. You may be required to do air sampling. You will be required to do weight tests. So you have a long-term maintenance obligation that is going to go on for you that is obviously, from a facility's point of view, is an operating cost that needs to be built into your budget. As such, weighing what the cost might be to remove PCBs versus encapsulating it, you need to be looking at life cycle. You don't just look at the capital to say, oh, well, taking this out is going to be this much money, whereas if I was just simply to encapsulate it, I'm going to save quite a bit of money, but you're going to then live with a long-term obligation. You're also going to have to put a deed restriction on the building or the section of the building where the PCBs are, so that those materials, when the building is finally demoed, there's a record that says that these materials are present and that you have to go ahead and deal with them accordingly. Encapsulation is simply, as you can see in the bottom left-hand corner, that you add different materials and encapsulate them. And one of the things that EPA looks at is whether or not you're going to have an exposure issue. Or if you're in an area that's like a utility plant and it's in a room that has high electric transformers, there's not going to be a lot of people in that space on a regular basis, and as such, the cleanup, how clean it needs to be, is going to be much higher than an area where you have a lot of people walking through it on a regular basis, and you can see the numbers, 6.7 hours per week. You also get into questions over whether or not the material that you have. For the longest time, EPA was looking at, they wanted you to encapsulate the material with 2 different coats that were in different colors, such that you might have a blue coat overlain by a red coat. Now think about that on the outside of a building where you have this red painted around the window. I mean, you're essentially looking like a bullseye out there, and you're obviously going to get occupants and everyone else being concerned over what is going on. You know, why is that building having red paint out there? You know, what's going on? And again, you're just starting to get people to be concerned about what's going on in this building that they work and live in. And again, back to communication. This is very similar to what we have is related to asbestos. These things are all key to be able to deal with the issue that you have, and be able to make sure is that both your occupants and your employees are able to understand that they're being properly protected, that they're not being unnecessarily or exposed, and that you're doing everything to make sure that they're safe. And again, we're back to questions. Hopefully I've given you a bit of information to deal with that you can look at, use it to kind of have an idea when people are coming in and telling you, consultants or regulators, that you have issues and how are you going to deal with them. Some of the language that they will use and throw around, you have an idea what those words may mean, such that you can go ahead and say, okay, I have an idea what it is. I can make sure I get the right people in here to help me going forward. I want to thank you for your time, and hopefully this has been helpful. Tom has been recording this, and I'm sure he is going to send these slides to be available to anyone to take a look at in the future. So please feel free to, if any time, to send questions to Tom. You can pass them on to me. I'll be more than happy to give you feedback, suggestions, ideas. My own experience, I've been a professional witness in court on PCB issues and have been working with the PCB world for probably over 30 years now. So it's near and dear to my heart. So thank you and have a good day.